We're on page 96 of the Student Journal, section 4.2, writing equations in point-slope form. Last section was writing it in slope-intercept form. Why do they call it that? Because you just need a slope and an intercept. Or by looking at it, then you can immediately identify the slope and the intercept. In this, what you will identify immediately is a point and the slope. So we will not know the intercept just by looking at this in this form, but again, it's just trade-offs. They have different forms. They're the same thing as just lines, but they just look a little different and they give us different information. So I'm gonna clear that. We're gonna move past all this, and we're just gonna go straight to the meat of it. Core concepts: point-slope form. A linear equation written in the form y minus y1 equals m times x minus x1 is in point-slope form. The line passes through the point x1, y1, and the slope of the line is m. So really all you need is a point, and whatever point they give you, you will use that, and then a slope, and whatever slope they give you, you will use that. So for instance, let's say slope is 5, that is up 5 over 1. And for the second example, I'll do, let's say, negative 2 over 7. It means going down 2 and over 7. And these are just examples, guys. Let's say a point on the line. Anywhere on the line might be like 3, 1. Okay, so for example here, and for my other example, I will say some point is negative 1 and 4. So what that will look like is this is x1 and y1. So using this format, we'll say y minus 1 equals 5 times x minus 3. And so if you look at this, you can know, oh, okay, well the slope is 5, and the the point, or a point on the line, is 3, 1, which is fair because that's what I started out at. Here, again, you would say x1, y1. You say y minus 4 equals negative 2 over 7 times x minus negative 1, which is really x plus 1. So we have y minus 4 equals negative 2/7 times x plus 1. So to go from point-slope form to slope-intercept form is pretty simple. You just have to distribute the slope and then isolate y by, in this case, adding 1 or doing whatever you need to do. But just while we're getting started, this is the point-slope form, and this is the point-slope form. Y minus y1 equals 5 times x minus x1. Don't worry, we're going to get a lot more examples in this. So write an equation in point-slope form of the line that passes. So as a reminder, y minus y1 equals m times the quantity of x minus x1. So here we have x1, y1. Say y minus 1 equals negative 3 parentheses x minus negative 2, or just y minus 1 equals negative 3 x plus 2. That's it, guys. I will show you one dealing with zeros so you guys know that when you're dealing with 0, basically nothing happens. So y minus 0 equals 4/3 x minus 5. So y equals 4/3 x minus 5. Here the x is to 0, so if I'm saying x minus 0, that's just x. So you'll get something like y minus 4 equals 7. X minus 0 is just x, so I'm just going to write 7x. There it is. If you want to, that's fine, but you would also simplify. So So this is your final answer. Y minus 4 equals 7x. These are all point slope, point slope form. That's just so you guys can do the other three for practice. Here. So we have to have a point. It does not matter which point. You could say this is the point, or you could say that is the point. It does not matter. For the sake of this problem, I will just say x1, y1. Find the slope. 1 up 1, 2, 3, 4 over 2. So m is equal to up 4 over 2. If you want to use the formula for rise over run, y2 minus y1 over x2 minus x1, that's fine too. This is just faster. Or to me personally, I think it's easier. So you have m equals 2, and you need a point. Well, you could pick this one. You could say y minus negative 2 equals 2 times x minus 1. And that really turns into a y plus 2 and everything on the right. Sorry, y plus 2 and everything on the right just is the same. And that's it. For the sake of the next problem, let's see, we could go down 1, 2, 3 over 1, 2, 3. So m is equal to negative 3 over 3 equals negative 1. So the only thing that's hard in all this is to find the slope first, which again is not, or should not be hard. You had a lot of practice with it by now. You can call this your x1, your y1. And just to give you an example of whether or not, some of you guys might be asking like, oh, does it matter which point we plug in? Well, let's see. And in fact, I will leave this, and I'm just working on number 7 alone. So if I do this and I say y plus 2, I'm just going to type it out because it's going to be a little faster. Y plus 2 equals 2 times x minus 1. If I distribute that, I get y plus 2 equals 2x minus 2. I subtract 2 on both sides, I get y equals 2x minus 4. Right? If you're not sure what happened, all I did was subtract 2 on both sides. And this is a y plus 2. So I'm going to well, I'll leave it there so that we can see. The next form is if I use the other point as my x1 and y1. So I'll say y minus 2 equals 2, my slope is not changing, x minus 3. So again, what am I doing right now? I'm showing you guys whether or not the point that you choose matters. So I'm pretending right now that this is x1 and y1. And if I distribute it, I get 2x minus 6. If I add 2 to both sides, so that will look like plus 2, I get y equals 2x minus 4. Voila! They are exactly the same. So, what does that mean? You can pick either one to be your x1, y1. It does not matter. So whether you write it like this, that's okay. Or if you write it like this, that's also okay for number 7. The same goes for the rest of these. So really just make sure you find the slope first, and then you can pick a point and use it to write the equation in point slope form. Oh boy, this one's asking us to write it in slope-intercept form, which is what I had done right here. So this is actually the answer. Sorry, my apologies. This is slope-intercept form. This is slope-intercept form. So after you do all this good stuff here, you distribute and you basically isolate y. You get y by itself, and that will be a slope-intercept form. Nice, convenient that I already did that without meaning to. So you do the same. To give you guys one more demo, I'll do number 10. Let's see here. So we have, let's find our slope first. So we could go from this point all the way over here, but it also looks simpler that it's crossing 0, 0. So go down 1 over 1, 2, 3, 4, which is down 1 to the right 4. And our point is negative 4, 1, so which one do you guys want to pick, x1, y1 or x1, y1? Let's just go with the right just for kicks. So we have y minus negative 1, which is really y plus 1. Again, I said y is minus negative 1, which is y plus 1, equals negative 1/4 times x minus 4. I'm going to distribute this. Negative 1 over 4 times x. So I'll just write over here so we have more space. Y plus 1 equals negative 1/4 x. Negative 1 over 4 times negative 4. Negative 1 times negative 4 is positive 4. 4 divided by 4 is positive 1. I have a plus 1 over here. I'll subtract 1 on both sides, and I get y equals negative 1/4 x. Slope-intercept form is y equals mx plus b. I got the slope here is negative 1 over 4. Where's my b? It is nothing because at the origin, which is also happens to be the x and y intercept, it's just 0, 0. So there's nothing for me to do there. There's no y-intercept, or the y-intercept is 0. Alright guys, let's see here. I have some more practice. Write a linear function f with the given values. So how do you do that? You have to find the slope. How do you find the slope? Before you find the slope, it's best if you just write it as ordered, or it's not best, I just think it's just easier for you. So to write it as an ordered pair. So right now we have, and I'm just going to write them out just so you can see what's happening here. So this is the input is x, and then the output is y. The input is x, the output is y. The input is x, the output is y. The input is x, the output is y. That applies to all these. And it says write a linear function. It doesn't tell you what form it's in, but in the section we are in, it's point slope form, or that's what the section is dedicated to. It will be a lot easier then. So everything we need to do is we need to find, the first thing we need to do is find slope. So this is x1, y1, x2, y2. And a reminder, the slope for formula is y2 minus y1 over x2 minus x1. There's definitely a better place I could have written that. In any case, we have 4 is our y2 minus negative 1 over negative 2 minus negative 3. 4 plus 1 is 5. Negative 2 plus 3 is 1. We have a slope of 5. Continuing this, we can pick this point or we can pick this point. It doesn't matter. I will just stick with this one right here as we write our point slope form. Y minus negative 1 minus negative 1 is y plus 1 equals slope times x minus x1. X minus negative 3 is really x plus 3. This is point slope form. We have finished this problem. If you want to write the function in slope-intercept form, I will show you. 5 times x, 5 times 3. Y plus 1 equals 5x plus 15. Subtract 1, subtract 1. Y equals 5x minus plus 14. So this is your slope-intercept form, and this is your point slope form. You're not required to do both. I'm just showing you for the sake of showing you, for those of you who want to know, or for those of you who want to know ahead of time, or whatever. Moving on. Linear equations. So remember that if it's a line, it has to go up. It has to be a straight line, right? So it could look like that. It's going up by the same amount, or it's like that. It's going down by the same amount. It has to be consistent though. So like you will never find a linear function that looks like that does not count because it's going down, then up, then down. Or let's say you had something that looked like this, so it's going down by an even amount and then it goes down by a ton. That does not count because it's not consistent. So let's see, let's clear this. Let's look at this. We go from -3 to -1, we go up by, 2. We go up by 1. We go up by 1. And we go up by 2. Here we go up by 50. So first of all, this already does not look consistent, but we'll just keep going through it. From -60 to -35 is plus 25. From -35 to -10 is also plus 25. But from -10 to positive 40, that's plus 50. So I don't know. Why don't you guys take a second to make a guess? Do you think this that this counts as a linear equation? How does that work for you? Well, the truth is it is, because for each one that it goes up, it's going up by, the y is going up by 25. So even though this x went up by 2, well, if it's going up by 25 for each one, then 2 times 25 is 50, which lines up with our expectations. I'm going to write this in slope-intercept form because we have the intercept right there, and we know the slope is going up by 25. So this is going to be real simple. Y equals 25x. It's going up by 25, so it's a positive because it's going up. Minus 35. That's your intercept. This is your intercept right here. 0, -35. If you wanted to do it a different way, which you could, if you work it out similar to these problems, you just have to write ordered pairs. So for instance, some ordered pairs in this might be -3, -110, and 340. And you break it down into your point slope form by saying x1, y1, x2, y2, finding the slope, doing y2 minus y1 over x2 minus x1, and then picking a point, this one or that one, and rewriting it. Okay, so sorry, it asks you to explain. So how will I explain this? Yes, the data can be modeled by a linear equation because it is constantly increasing by 25. Okay, this one, let's see here. We jump up by, wow, 98, 100, 120. And then, wait, did I say that right? -98 plus 98, or -98 to 18 is 98 plus 18. Sorry, that's 116. That's 116. So 116, we have minus 10, and we could pretty much stop here. A line, like I said, will not go up a bunch and then go down some. That does not make any sense. We could just stop right there. No, the data can't be modeled by a linear equation because it increases and then decreases, right? It's supposed to be increasing or decreasing at a similar, or sorry, at a constant rate, right? So in number 19 is consistently going up by 25. In this one, there's no consistent direction, so that doesn't work. All right, guys, that's it for this section. Hope you guys understood linear point slope form and lines a little bit better. If you don't, or if you still have any questions, make sure you ask your teacher or let me know.